Chambliss, this first one says use the graphing method to solve the system. Okay? What do I need to do first?
Well, first we need to get y by itself.
Okay, let's take this first one. 4x plus y is equal to -3. What should I do?
Subtract 4x.
Subtract 4x from both sides. And that's going to give me y is equal to -4x minus 3. Okay? Is that good? You like it like that?
Can you do -4 over 1?
Of course. That's our slope, right? So we got rise over run. Good. So, thank you, Chambliss. Perfect. Robert, help me graph this thing. What do I do?
So you're going to go down to -3.
Yep.
Y-axis.
Got it.
And we're going to go down 4
Yep.
over 1.
Down 4 over 1. Okay. Now, when we're graphing to solve a system, what do we normally do with these points? We don't normally do this if we're just graphing a line. But when we're trying to use the graph to solve, Cameron, what do you think?
Do we like not make lines out of them?
I don't make lines out of them. I just keep putting more points using the slope. So if I go down 4, I kind of have to go off a bit here, but it'd be about right there. But what else? Can I do something else here? What do you think, Duncan?
Go up 4.
Up 4
Back.
and back 1. That's still a negative slope. Up 4, back 1. Up 4, back 1. Okay, I like it. Now, who wants to take the next one for me? Lily, thanks. What do I do?
Alright, so you have to do negative. Okay, what are you looking at? Doing it English.
I'm waiting for you.
I'm sorry, I accidentally got some pads and I actually need to. Okay, so you subtract -5x from one side and then negative.
Subtract 5x.
5x. Yes, and then subtract 5x. Okay, so then it's -y equals -6 minus 5x.
How about -5x minus 6? We want to put that in front. Do you like it to be...
I don't like the -y. So
Okay.
y equals 5x.
I'm sorry?
Y equals...
What are you doing?
Trying to multiply it by -5.
Multiply this side by -1, multiply that side by -1,
Okay.
and that gives me?
Y equals 5x plus.
Okay. What would you like to do from there?
So start from the x into up 6.
Oh,
No,
okay,
up
I see what you mean.
Yeah.
I see what you mean. 1, 2, 3, 4, 5, 6 here?
Yeah.
Okay.
Then the slope would be up 5 over 1.
Up 5 over 1, right? There we go. Now, this kind of takes me off the graph a bit, but I'll put it right there.
Okay.
What can I do to find some other points?
You can do -5, down 5, and then down, or then over again.
And then back 1, sure. Okay, so 1, 2, 3, 4, 5,
And then over.
and then back 1.
And over
Okay,
again.
excellent. So what is the solution for this one?
-1,
Mm-hmm.
then 1.
Okay. Okay, good job, Lily. Let's look at this next one. All right. Number 2, use substitution method to solve the system. What should I do? Drew?
Okay, so the easiest one to get rid of by itself is the right one.
Okay.
So you want to add 4 in to both sides so that you can get it by itself.
So Drew says that I need to add 4 in to both sides, get m by itself, because that's the easiest one. So that gives us m is equal to 4n plus 6. Good. Now what?
So now you want to take the second one and you want to plug in what you have for n now in the n spot.
Plug that in right
So you
here.
have one there.
Excellent. Now, Allie, what's that give us?
That gives us 3n plus 5, and then in parentheses, 4n plus 6 equals 7.
Okay. All right. Where do I go from there, William?
3n, or excuse me,
Uh-huh.
3n plus 20n plus 30
Uh-huh.
equals 7.
Excellent. All right. And how about from there, Alex?
Okay, so then you want to subtract 30 from both sides.
Okay. I can do that. I'd rather simplify before I start solving.
I just do it in kind of like one step, and then below that you do 23n equals.
So you put these two together,
Mhm.
and you've made it 23n is equal to what?
-23.
Negative 23.
Then
And go ahead and finish it.
Okay, you divide each side by 23.
Yep.
N equals -1.
Excellent. Now, from there, where do I go?
Okay, so For m equals, for
Uh-huh.
m plus 6, you can plug -1 in.
Plug -1 in for n.
Yeah.
All right, because we know that's what it equals. So 4 times -1 plus 6, what do we get?
So you get -4 plus 6.
Uh-huh, and that equals? Good. Now, is that the way we want to present our answer?
M equals.
Okay, but is that the way we want to present it?
No. You
No.
have to put them in order.
Put them in order. So put them in an ordered pair. What do we get first?
And so m to -1.
All right. Perfect. Nice job. And you know your alphabet.
Yep.
Well done, Will. All right. Okay, let's see. Number 3. Again, it says use the substitution method to solve the system. Cameron, why don't you help me out with this? What do I want to do? Or what would you do?
I get the first equation, I get y by itself.
Get y in the first equation by itself?
Subtract 5 from both sides. So it'd be
Oh,
y,
hang on. I made a mistake. There we go.
y equals 2/3 x minus 5.
All right. And where do I go from
Then I
there?
plug the right half of the equation in for the value of y in the second equation.
Excellent.
So it'd be 4x minus 6 times 2/3 x minus 5. And then that equals 30.
All right. Now hang on there. Okay. Thank you. Duncan, what do I do?
Alright, so just start distributing.
Okay.
4x minus 4. 4x.
Okay.
Then it's plus 30.
Plus 30. Got it. Okay. Equals 30. All right. Keep going, Duncan.
Alright, then the 4x is crossed out.
The 4x's cancel out. What am I left with?
30 on 30 to 30.
And what does that mean, Steele? Exactly. Infinite solutions. That means that any solution for this first equation will also be a solution for the second equation. When I get a true statement like that. All right? Nice job, Duncan, Cameron, Steele. Well done. All right? Infinite solutions. There we go. Make sure that's your answer. Not like true, a lot, something like that. Okay?
Uncountable.
All right.
Uncountable solutions.
Example number 4, use the substitution method to solve the system. Who have I not? Hey, I haven't talked to Lake. Lake, what do I do?
Well, you already have one equation already written, so you can
I
plug
do.
it right into the next one as
Lake says I've got y by itself already, and I can plug it right into this second one. So what does that give us, Lake?
6x minus 2 times 3x minus 7.
All right. Equals 12. Nice. All right. Take us from there, Miles.
Okay, 6x minus, let's distribute, minus 6x, sorry, minus, or plus 14. I said minus.
You okay?
That's a plus, yeah.
All right.
I said minus twice, so it cancels itself.
So what happens here?
So that 6's, let's simplify, they basically cancel.
Okay.
And we get 14 equals 12.
Now hang on, Miles. What? Hang on, Miles. What does that mean, Andrew?
That means no solution.
No solutions. Now, Andrew, because this isn't true, it's a contradiction. Okay, so no solutions. But think about it for a second. This equation has infinite solutions. It does. There are things that make it true. This equation has infinite solutions. But they don't have a common solution. That's what we're saying here. There are no solutions to this system. There are solutions to each one of the equations, but not a solution that works for both of them. Okay? That's it. Nice. Yeah, Miles.
So if we tried to graph it, what would it look like?
If you tried to graph this, what would it look like? Cameron?
Wouldn't the lines be parallel?
They'd be parallel.
Okay.
Okay?
Alright.
The lines go on forever and ever, but they never intersect. If they do intersect, then they have a common solution. It's that point where they intersect.
If they're the same lines, infinite solution.
If they're the same line, then it's infinite solutions. So if we went back to this problem, infinite solutions, the graphs for both of these equations are exactly the same. The graphs are. They're different equations, but their solutions, because a graph is a picture of all the solutions, their graphs are the same. Okay? Nice. All right. Use the addition or subtraction method to solve this system. Eva, help me out with this. What would you do with this? It says 4a minus 7b equals 13, and 2a minus 7b equals 3. What would you do?
Okay, when you put the second equation under this equation, minus
Just
that.
take this one and put it right under. 2a minus 7b is equal to 3. Okay?
Okay, and you're gonna want to add 30 because then the 7b and then the 7b. Oh wait.
Now wait. Can I draw my lines? Because I like to draw lines. Is that all right? That makes me feel better. Okay, now I'm ready. Do I want to?
Track.
Okay, hang on 1 second, Eva. Wait. This one's 13, but that one's 3. So when I wrote it underneath, I'm just writing 3. Does that make sense? You with me? Okay, thank you for watching out for me because you know I make mistakes. Eva, do I want to subtract these things or add them?
Subtract.
Exactly, because they're the same sign. If they're the same sign, then I subtract. If they're opposite signs, I add them. Okay. Subtract. 4a minus 2a. All right. Negative 7b minus negative 7b. They cancel. And what's 13 minus 3? Good. Where do I go from there, okay? Thanks, Evan.
Okay, so then divide by 2.
Divide by 2, and I get
5.
a equals 5. Now, Robert, Will has told us that a equals 5. What do I need to do now?
So you're gonna want to plug the A into the 2, or no, you're gonna put the A
Yes?
in the 2A, so 2 times 5 equals 10.
2 times 5 minus 7b. You want to plug it into the other equation?
Yeah.
Beautiful. Okay, so
And
you want to simplify it?
So yeah, 10 on both sides. Or you want minus 7b
Okay. You okay?
equals 3, and then minus or subtract 10 on both sides.
Subtract 10 from both sides. Good.
And then 7b or negative 7b.
Okay.
equals negative 7.
It does.
So b equals 7. 1.
Okay. All right. And so b equals 1. Is that right?
Yes.
Okay. Excellent job. Thank you, Robert. Now, how do I present it, Lily?
Alright, well, so you have to do it in alphabetical order, so it'd be 5,
5, 1. Beautiful. In an ordered pair. Nice. All right. Now, I'm going to stop this video, and we'll finish on the next video.